Thanks for joining. So today I'll discuss the intersection between XR and 5G, but from a Collabora and open source point of view. Next slide. And so, yeah, I'm Fred. And since I'm really new to the action group, I thought I could present myself, make kind of a more general talk to you, present myself, present what we do at Collabora, and what's related to the working group's interest. Like those are going to be real use cases that we're working on. I'm going to talk about that a bit later. So I have two affiliations. So XR lead at Collabora, where I'm leading a team of very talented XR engineers, as well as working on more strategic things, aligning our open source R&D projects to the market trends. So we also have that part. For a consultancy, I have an interesting R&D budget every year. You still hear me well, right? I heard someone.
We hear you well.
I think, yeah, there was some audio coming. Oh, that's okay. I'm also outreach officer for OpenXR at the Kronos Group, where I work with the marketing team there to spread the word about OpenXR. So I got to know the 5G Mac working group at the XR Expo conference last month. And since I think most of you folks already know about Kronos, anyway, there's so many things I cannot talk about because it's all under NDA. But you maybe don't know Collabora that much, so I'll spend a few minutes presenting my company to you folks. Next slide, please. And so at Collabora, open source is very important. It's at the core of what we do. It's in our NDA. It's in our DNA. And so our raison d'être is to accelerate the adoption of open source technologies, methodology, and philosophy. Next slide. And we are a global consultant company, delivering open source solutions for in various industries for 20 years. And we have offices in Montreal, Canada, Cambridge, UK, where we hire, I think, like around 50 folks. And the rest of our workforce is spread across the world, where we sign one-on-one contractual relationship with specific open source hackers and people, and also making sure that we treat our people equally with regards to cost of living and inflation. So that's a pretty cool work model, I think. And so we have the usual certifications for processes, quality, and security, as well as the open chain one, which is not well known, should be better known, but that's the international standard for open source license compliance, and you can check it out. I will upload the slides afterwards. There's many links in there. And so next slide. On page 5, this is pretty much what we do, right? So we try to maintain a strong presence at international events and conferences, striving to educate about open source all the time. We also offer training, notably around GStreamer. That's our multimedia framework. But mostly we're engineers, right? So we code. That's what we do. So we build, we integrate kernel, platform level software, firmware for the industries that we will see on next slide. But we also maintain, on the right-hand side, we also maintain the very important Apparatus Linux distro, which is a Debian-based multi-arc distro that's being used right now by key players like Bosch and Atari. Next slide. And so here are the industries we're working in. So, I mean, it's embedded, right? From silicon to embedded, automotive, TV signage. So we have very strong graphics, multimedia, core domains. And since a few years now, we also have a machine learning AI domain, working on cool text-to-speech stuff and LLM in the open. We're trying to free the models and give it to the world. So some announcements coming up. And of course, for XR, the domain that I'm leading, we're helping our customers leverage OpenXR, of course, OpenXR enablement, accompany them towards compliance and in various subsectors like XR platform, headsets, 3D stereoscopic displays, XR streaming, and more recently, the intersection between AI and AR. Next slide. And so more specifically now about XR at Collabora, we are, as you might know, we are key contributors to the OpenXR standard at Kronos. We are spec editors of the standard, and also CTS contractors, so writing the OpenXR compliance tests in accordance to the working group priorities. And we also are involved in OpenXR outreach activities and try to be at the trade shows and give talk on behalf of Kronos, things like that. We're also initial authors and key maintainers of the now, I think, well-renowned open source OpenXR runtime called Monado. And so next slide, we're going to take a look at that. Actually, yeah, next slide. And actually, yeah, I think that's pretty much it for us. So I think enough about Collabora now. 5G Mag group, right? So which I got to know, as I said, at XR Expo in Stuttgart, Germany last month on May 9th. Pretty good date, by the way. But it seemed to me like we have a common goal, and so at least from my XR perspective, G5 Mag and Collabora are working at bridging the gap between standards and developers. And of course, you folks being more, I think, on the media side, you work more with 3GPP and MPEG Dash, while we are more working on the Kronos side in OpenXR. So from my perspective, right? So I've already taken a close look at the 5G Mac reference tools, GitHub repo, the projects that are there. I can already tell that there's potential for converging on some projects. For example, the XR renderer that you got, the RTP header extensions work that I saw, that's something that we also worked on in the past. So I think this is just the start, and we're probably going to be connecting on some other topics after the call in the coming weeks. And so next slide, please. Now talking about bridging standardization gap on our side, here's our killer project, Monado. So created in 2019. So even if we're initial authors and key maintainers, it's important for me to say that Monado is a community project, right? It's owned by itself. It's not Collabora's. That's important for us. And so Monado is a modular OpenXR conformant XR runtime that's open source with permissive license and cross-platform. So it builds and runs on Linux, Windows, and Android. And think of it as a construction kit for a runtime, right? So it's pretty loosely coupled. It lets you use Monado, for example, only for its robust OpenXR API and state trackers. You can also easily extend our template XR compositor to integrate your own logic. You can add your own devices drivers to support custom hardware. And talking about drivers, Monado's comes built in with 37 drivers, device drivers for sensors, for cameras, for HMDs, but also there's built-in SLAM and machine learning based hand tracking in there. So that project's called Mercury. So pretty cool stuff. You should check it out if you don't know about that already. And so graphics wise, I just have it. Yeah, one more sentence. Graphics wise, Monado's using Vulkan internally for composition, but offers OpenGL, Vulkan, D3D11 and D3D12 graphics bindings for clients for connecting apps. And then next slide. And so since its inception in 2019, Monado has seen steadily growing adoption among XR platform vendors and other OEMs, with the number of contributors increasing tenfold. So we're pretty happy about this. We're working on Monado all year round with an average of approximately 100 commits a month, and apparently a preference for spring in the Northern Hemisphere, something I didn't know about. I thought it was funny. Next slide, please. And now the new baby, pretty new baby called Electric Maple, created in 2023 in collaboration with Pluto VR in the cloud gaming industry. And so this guy is an XR streamer based on two famous open source projects. So GStreamer for all of the codecs and transmission protocols, and Monado that we just saw, right? So it currently has its server side working in Linux, supporting, of course, VR, but supporting AR mode via chroma keyed base environment blend mode. It works on NVIDIA and AMD hardware and Linux, leveraging either software x264 or hardware AVCH EVC codecs in there via NVENC and VAPI. For connection and transmission, it leverages GStreamer's WebRTC with data channel both ways, with the signaling server that's currently living on server side, but soon enough we'll have the signaling server totally decoupled and made as an independent component. Client side currently supports Android platforms. It's also GStreamer based, GStreamer on Android. And Electric Maple comes with a reference simple receiver app that also open source, that has been tested working on Quest devices. But since it's OpenXR, right, I also tested on some other platforms, and it shall be working more than on the Quest devices. Now, note, however, that one limitation that we have right now, and it's not in our roadmap, but it's not so challenging, is that there's no audio support right now. We haven't really worked on audio capture on server side yet. One word about licensing here, and that's before we switch to the next slide. One word about licensing is that the reason why we came up with yet another streaming solution is that, contrary to similar solutions in the open, Electric Maple licenses are permissive, but also proprietary code friendly, and of course free of patent encumbrances, of course. But this makes it very easy for XR platform makers and OEMs to build their solution on top of it. And usually what we do is, as we work with those guys, it's a win-win, right? We educate about open source, and most of the time we convince them to upstream general purpose patches in the upstream project, and everybody's happy, right? Next slide, please. Very quickly, so a little glimpse about our roadmap for that project. So we'll have full controller support, all done. It's half done, all done like imminently. Like few weeks. No haptics, however. It's just going to be pauses and input. We're working on zero copy Vulkan pipeline, also available pretty soon. We also have a Windows port that just needs some love. It's living in a branch right now, and that's almost ready for server side. We're also planning on adapting proper alpha, adding proper alpha support for true AR mode. And so if you guys are interested in that project, clone the project, start playing with it, take a look at it. You have the links down below. And of course, contact me after the talk. I'll be really interested to continue discussion on that. And so next slide, please, on page 13. I think that's it for open source projects. Now, about the intersection between what we do, so XR and 5G, right? So next slide, I will give a little summary of where we are. This is probably trivial for most of you. So as you know, the XR market, that's my analysis from what I see from customers, right? So the XR market is expanding super rapidly. It's going to enterprise sectors, from manufacturing, maintenance to remote collaboration. So of course, with that growth comes new expectations, right? And so users, I see it now, demand photorealistic graphics, high resolution, high frame rate, accurate object tracking, they want it all, right? And of course, keep the latency so low. And so this is becoming a problem. And I think with the 5G use case in mind, we're also seeing now a need for true mobility, right? Wireless, lightweight, and this is coming. So we're working on POC right now, but I think in 3-5 years, it's going to be about all-day wearable XR. And so meeting those expectations come with challenges, of course. The form factor of XR devices being, shrinking, it limits compute, graphics power, as you already know, makes power consumption a critical constraint. And in parallel, I think we are at a pivotal moment, and this is important. I think we're, the intersection between XR and AI. I think this might just define the next big wave in consumer tech. market, unlocking smarter, more compact mobile form factor. And so on the next slide, when we talk about that, take a look at this. We can't ignore, of course, the promise of 5G and 6G, right? Because of the high scalability, the ultra reliable low latency, with the very charming 1 in 5 milliseconds promise, right? But there are still, of course, real challenge, as you all must already know. So the issue is range. Current 5G networks still struggle to deliver low latency across, for a moving client. 6G, I think we're facing a problem for placing a large number of little antennas on small form factors. And so this, just a quick, we'll dive into actual use cases that we have been working on. Just a quick note. We at Collabora are not 5G or network infrastructure experts per se, right? But we've worked closely enough with these technologies to understand what's relevant from the XR perspective. And so the next 4 use cases I'll talk you through are real world examples that we've directly involved in, either POC or projects. I cannot say that much more than that. But another disclaimer that I have for you, and I wrote it in here because it's important. I'm going to read it. And so the companies that you'll see mentioned in the upcoming slides are included here purely for illustrative purposes, of course, right? They help show what's happening in the XR space around me, but their mention doesn't imply any current or future business relationship with us, or shouldn't be taken as a reference to existing clients or collaboration. And so on next page, please. Here's one use case that we are seeing a lot. We're clearly heading into the next big consumer wave, I think. So with AI-powered optical see-throughs, mixed reality glasses. And we're seeing an exciting signals across the board. For example, Snap, they launched their 5th generation spectacles with head tracking, hand tracking. Meta's upcoming Hypernova, expected to land this year with model display. Probably 2027 with the dual display version. Google, as you might have seen, Google I/O 2 weeks ago, they are pushing Android XR so hard and teaming up with, for example, XReal for the smart glasses and well-known, lens makers to bring stylish and tech-enabled glasses to the market. And so this is happening right now. The roadmaps are being defined. There are some announcements for that gear to come out. But there's a challenge, right? Again, compute and power dissipation technologies simply just can't keep up with the growing ambitions of AI-driven AR. So seems like lightweight XR just doesn't have the thermal headroom or processing power needed for everything they want to do, right? And so that means, in my perspective, that we're probably going to see a big shift toward compute offloading. Tasks like SLAM, high-resolution rendering with global illumination, hand tracking, gesture tracking, scene understanding, and probably other complex spatial calculations will probably get increasingly handled off-device. And so, of course, this puts the spotlight back on networks and standalone 5G and technologies like network slicing for potential monetization strategy on your folks' side. I think those are all still being perceived as viable thing, in the 3-5 years horizon. At Collabora, so we've already started working with customers on remote rendering and split rendering solutions, including leveraging open source stack like Electric Maple that I just mentioned. We are also collaborating with players in the 5G space to explore how streaming APIs could be standardized in order to build a strong developer story that can accelerate adoption. I cannot give much more detail about this, but yeah, we're trying to take a look at the standardization aspect. And so next page, please. I only have like three pages, slides or so. I know we're running out of time, but tell me, okay? Another use case, right? What about industrial surveillance? Now, most of you already know about this, but yeah, we're talking about a fleet of drones scouting complex industrial sites like a power plant. These drones would use AI analytics in real time, in real time to detect potential issues, and then they can flag problems and relay to remote operator, right? That operator would be equipped with an XR headset or XR gear and can, control a narrow field of view gimbal camera on the drone by moving their head. The system tracks head pause and instantly adjusts the camera's orientation. So this setup is extremely, latency sensitive. We are working in POC phases, but I guess it would call for private 5G. So offering low latency, but also scalable bandwidth needed to support entire fleets of connected drones. And so as a preview of what's coming next, we are also working on remote presence projects, POCs actually, for remote presence via humanoid robots. Those robots will be piloted in real time through XR as well. So this is really interesting things that's happening right now. Next page for the next case that you already know. So remote assistance is pretty typical, right? This slide shows what the classical XR remote assistant is. Very quickly, so that's a setup that's already widely used. On the left, you have the on-site worker wearing basic smart glasses, right? They're camera only, not spatially tracked. And these glasses stream a live video feed, of course, to remote expert who's typically sitting at the workstation on the right? And they have two-way audio, and the remote assistant can guide the worker in real time, looking directly at what the worker sees, right? It's simple, it's effective, especially for tasks like diagnostics and field maintenance. But I've seen, we have companies that find this limiting because of lack of tracking, lack of interaction in spatial context. So on next slide, you'll see what I call the enhanced XR remote assistant. You still here? I don't see this slide, the enhance, right? Thank you so much. And so this is what I call the enhance XR remote assistance use case. On the left, you now see the same on-site worker, but equipped with a 6 degrees of freedom inside-out track glass that streams RGB video, but also spatial data back to remote assistant. The same remote assistant now shown on the right sees a now spatially enhanced camera feed and can actually draw annotations that are anchored to the real-world surfaces using the tablet or most typically a 3D mouse. And these visual cues then will appear in the worker's view, correctly registered and locked onto the real-world object. So that's pretty cool. Of course, combined with two-way audio, this system now allows the assistant to guide the worker step by step, almost as if they were physically present. We're working on a POC right now for this. So, this will probably call for the infrastructure. We have to understand that this is happening. And because of the high, of course, level of compute offloading happening here in that use case, right? This is latency critical. Also depending on the worker and assistant co-locality. 5G here in networks infrastructure is probably a good enabler for those specific use cases that I see quite frequently. And so next slide, please. Page 20, we'll take a look at another, not so much working about this one, but I've seen it coming. So that's probably one of the most critical high-stake application in XR and 5G, so remote surgery. In this context, of course, safely is not negotiable. So we're talking about procedure, of course, that a surgeon could be operating a patient from hundreds or thousands of miles away. That means we're dealing with ultra low latency requirements, not just for responsiveness, but for managing the risk, right? And that's where we evolved a bit. We had the experience. So good haptics is also super essential. The surgeon they have to feel what they're doing, almost if they were, physically present in the room. And now we are in the post Da Vinci surgical systems era, I think. And I don't have a lot of visibility, but I think people are working on next gen haptics there. Research I will post another slide with the references, right? You'll see, and I will have a lot of references, but research tend to show that to be safe, the true glass end-to-end latency, like total latency, must be under 200 milli for that use case to work. That is at the absolute maximum. Faster is better. But of course, here the latency must be guaranteed. So it calls for, I think, URLLC, but the cool thing is that since those procedures typically take place in fixed operating rooms, I think there's no space constraints for antennas and stuff like that. So making technical developments may be a bit more feasible. And so those are the use cases I wanted to draw your attention on, but there are way more. I had way more content for you guys this morning, but I had to make hard choices. I would be really glad to do a more technical XR talk in any upcoming XR edition of those calls. And if you could go to the next slide now, Daniel, I would now thank you for your time. And as I said, I will be completing the references in my slide and will re-upload or resend the slide deck to Daniel a bit later if you're interested in having the slide deck afterwards. Thank you so much.